This question says, you are given the task of testing the following hypotheses by first completing the topic and research question. Let's take a look what topic appropriate topic we can put there. Oh, so it marked tourist arrivals in 2000 and tourist arrivals in 2022. So the topic can be tourist arrivals. Tourist arrivals. All right. As you know, the topic, is kind of subjective, so you can rephrase it all you want to. Research question. So we're comparing the difference, the variation of 2000 and 2022. Okay, so the research question can be, has the number of tourist arrivals changed from 2000 to 2022? Or you can say, is the number of tourists that arrived in 2000 different from the number of tourists that arrived in the year 2022? Is the number of tourists, normally good to start a sentence if is now? I don't think so. I think it's a good idea to start a sentence with this. The number of tourists that arrived in 2000 different from the number in 2022? There are many other ways you can rephrase that question. Okay, but we get the idea. No. We can use a chi-square test for variation to do that. Okay. First, we have to state a pair of hypotheses. Step number 1. Since we are on a chi-square test for variation, this will be our pair of hypotheses. The observed values are equal to the expected. The observed values are not equal to the expected. For this course, that is what you put as your HO and your HE for a chi-square test. Goodness of it. That's your other statistical term for it. Variation. Bam. You can type it in or you can copy and paste it. So we're going to see if it's the HO or the HE. Step number 2, 3, and 4. Curve is right tail. Rejection region is on the right. The critical value is on the critical point, a positive number on the right. 9.348. This will be provided to you, 9.348, because a critical value approach. Step number 5, we have to calculate the test statistic. It's the same formula, the sum of O minus E all squared over E. But with the chi-square test for variation now, the historical values will be the expected values. The observed values is what you observe in now. The current values will be the observed values. The historical values will be the expected values. Please take note of that. Normally the E coming above the O, because the E is what happened before and the O is what you observe in now. Please bear that in mind. Take note of that. Then we have to calculate the chi-square test statistic. We have the formula predetermined there already. All we need to do is to insert those numbers here. The same formula. So the changes I'm going to do here will automatically give us our chi-square test statistic. The first observed is 700. That's what you're observing now. But what did you expect? What happened before? You expected a 6698. So please bear that in mind. What you observe now with this cruise ship, and these are, let's call that cruise ships. So in that ship in 2000, you got 6698. So you're expecting that, but no, that's what you observed happen in 2022, 700. And we all know why. You observed 709. No. But what you expected the 8017, because that's what happened 2000 years of in year 2000, sorry. Okay, so please bear that in mind. The expected is what happened. So you expect it to happen. If something happened already, you're expecting it to happen. Okay, and the observe is what happened in now. So you observe 781, but you expected 8032 because it happened already. Okay, so please bear that in mind. The expected is what happened already. The observe is what happened in now. A 996 is happening now, and we expected a 9015. Bam. And here is the chi-square test statistic. Don't worry about it because of the squaring. Right? That number, subtract that number squared will give you a very big number. That is normal with chi-square. Okay? Test statistics. We copy this and we put this in our text box. Here it is. Chi-square test statistic. Control V. All right. Round off to 2 decimal places. Okay. Come on, come on. Right. So now we have to put this on the curve. That is step number 6. Clearly, 25,000 is on the right side of 9 on the number line. This is not drawn to scale, it's not needed because you just want to know where the test statistic landed. So you don't have to be drawn to scale. Either the test statistic is in the unshaded or the shaded and the critical region. That's all you need. Is where the test statistics is, and the test statistics, as we can clearly see, is in the critical region. Okay. So this leads us now to step number 7. Remember, we know what is step number 7. Step number 7 says, if the test statistic is in the rejection region, you reject the null. Reject the null if the test statistic is in the rejection region. Do not reject the null if it is in the unshaded region. Where is our test statistic? It is in the shaded region. It is in the critical region. So we have to reject the null here again. So this stands. So since we rejected the null, then the HA is the conclusion. So therefore, based on the data, now we have a different HA. Remember, it's variation we're testing for now. So we have to quote what the HA is saying. What's our HA saying? Let's go back to the HA. Remember, you always start with 2 hypotheses. One will be the conclusion. So we rejected HO, so HA is the conclusion. The observed values are not equal to the expected values. Simple as that. So there was variation. What you're observing is not equal to what you expected. Therefore, based on the data, what is being observed is not what was expected. You can rephrase it, it means the same thing, all right? Hence, there was variation. I can even say significant. Significant is a very statistical term to use. There was significant variation in tourist arrivals. In tourist arrivals. And here you have it. Chi-square-test. Goodness of fit using the classical approach. Okay. Oh, by the way, I also almost forgot your you have to, for your working, you have to copy. I did not do that for the randomness. You have to copy the table to Control-C, Control-V to indicate where you calculated the, okay, the test statistic. Okay, so if you go back, right. And this is the one for the randomness. There it is. So make sure you copy and paste your calculations for the chi-square-test statistic, right? If using Excel.